In this last video, I'm going to focus on the Fall Midterm Review questions 41 through 48. This has a focus on parallel and perpendicular lines as well as transformations. This is going to be a lot of stuff that we covered here in this last grading period. Question 41 is asking us for an equation that is perpendicular to y equals 6x plus 2. When we're talking about perpendicular, we're talking about opposite reciprocals. Opposite reciprocals means that we have a plus and then a subtraction. So one that's positive, one that's negative. Reciprocal is another way for saying to flip the fraction. So we come over and we take a look at our equation and we see we have, it is in slope-intercept form and our current slope has a value of 6. So if we want a perpendicular, this is the symbol for perpendicular. I'm looking for a slope that is opposite. So here we're going from a positive value, which means I need a negative. And then reciprocal, I need to flip my fraction. Right now my slope is not in fraction form, so we can do that by change it by adding a 1 in the denominator. So we don't change the value. So we have 6 over 1, and when we take the reciprocal, we flip it around, that gives us 1 over 6. Our slope is negative 1/6, and then when we write an equation, we're going to have y equals negative 1 over 6x, and then your y-intercept can be any value. If you want to keep it the same of a 2, you can. If you want to change it, it's fine too. What matters is that you have the slope has been changed. Question 42, what is the equation in point slope form of a line that is perpendicular to y equals negative 1/2 x minus 8 and passes through the point 2, negative 3? So we're being asked to specifically write this equation in point slope form, which is y minus y1 equals the slope times the difference of x and x1. In order to use point slope, we need a point and a slope. We're focused on an equation that is perpendicular to this equation, which is in slope-intercept form, which means we have a current slope of negative 1/2. So our current slope is negative 1/2. Perpendicular is going to be opposite reciprocal. Since it's a negative, our new slope is going to be positive. Reciprocal means we're going to flip our fraction around. So instead of 1/2, it's going to be 2, which is the same as 2 over 1. But we don't need to write the denominator because it's a whole number. It's 1. The second part is the point we're given here. It helps for you to go ahead and label. This is x1, y1. So our x1 is going to come in the parentheses at the end. The y1 will go in the beginning. And of course we have our slope. So our equation is going to be y minus the y value, which we have is negative 3. So even though there's a minus, you still have to go ahead and put the negative. Equals our slope, which we have is 2 from here. Parenthesis x minus, and then we have our x value from the point, which is 2. Now this is correct, but I want to go back because we have a minus negative. that does change to a plus. And then this is our final answer because we were asked to write it in point slope form. This is point slope form. Once again, you will have access to a formula chart. Question 43, what slopes are needed to be parallel and perpendicular to 4x minus 3y equals negative 12? Once again, this equation is given us in standard form, not slope-intercept. So we need to change this to that y equals mx plus b format. So before you do anything, you're going to take that equation, use your inverse operations to isolate the y. So I'm going to draw my line through the equal sign. The first thing you want to do is to get the y term by itself, which means this 4x needs to go. It's currently a positive 4x, so the inverse would be to subtract 4x from both sides. The 4x's on the left are going to cancel out, leaving you with negative 3y equals a negative 4x minus 12. Now you can divide by a negative 3 because that's the coefficient of y. The negative 3's on the left cancel out, leaving us with y equals negative 4 divided by a negative 3 becomes a positive 4/3. We're going to leave it as a fraction, x, and then negative 12 divided by that negative 3 is a positive 4. Now we can see if we're talking about parallel, our current slope is 4/3. So our parallel line is going to be y equals 4/3 because it's the same slope. And then your y-intercept has to be different. You can pick any number you want as long as it's not a 4, because that's what we have originally. If you pick 4, then you have the same line, and we don't want that. So I'll just go with 7. The next part is creating a line that's perpendicular. So perpendicular, we have opposite reciprocal. So I have y equals. Right now this is positive, which means we need a negative slope value. And then we want to flip our fraction around. So our perpendicular slope is negative 3/4. That's going to go in our equation with your x. And this one, it doesn't matter what you pick for your y-intercept. It could be 4, it could be negative 4, whatever you want. I just picked 2. Question number 44, write the equation that shows the linear parent function, which is f of x equals x, and we're going to translate it to the right 7 units. Because we're going to the right, this is talking about the x values. We know it's the x values because when you have your coordinate plane, the x-axis is the one that goes left to right, and the y-axis is the one that goes up and down. So since this is targeting those x values, we want to make sure that we show our transformation inside those parentheses. So we're going to have g of x, which is our new function, is going to equal f. The f is coming from the original of x. And then this is where my 7 goes. And it's a minus 7 because we're going to the right and it's inside the parentheses, the sign will change. So right will always be a subtraction inside. If we're having to move left, then we're going to add. And it's going to go inside those parentheses. Question 45. This is the one I told you guys to put a star next to because this is one of the ones that we seem to be struggling with the most. And it reads given, and there should be an F here. F of x equals negative 5x. What is the equation of the line after it has been reflected? If we're going to reflect, and the only thing we're going to do is reflect, we need a negative. And that's the only thing you need. So our new equation, g of x, is going to equal f of negative x, or you could say g of x equals negative f of x. Depending if you're going to reflect across the x-axis or the y-axis will determine where that negative placement is going to go. As far as the test on your exam goes, I just want to know if it's reflected. So the negatives that either inside parentheses or outside is what I'm looking for. The most common mistake that we've been making on previous assessments or practices is that because there's a 5 in the original equation, a lot of people are wanting to put a 5 somewhere inside as part of the answer as well. And that's going to make your answer incorrect. So a tip for those of you who are taking your test and you're using this, if you see g of x equals f of negative 5, or you have a negative out there, if you see a 5 anywhere in the answer, it is wrong. Do not pick it. I promise it's going to be there, so don't pick it. Question 46, state how f of x equals 6x transforms when it is transformed to g of x equals f of 0.35x. So when you get a problem like this and you're asking about the transformation, it doesn't matter what the original problem is. You can just mark it through. You don't need it. It's not needed. You're looking at what it has been changed to. Here, we're looking inside the parentheses, and we are multiplying. Whenever you're multiplying, you're talking about the steepness. We are multiplying by 0.35. And 0.35 is less than 1, which means our graph is going to be less steep. Now on your test, you might have which one is steeper, g of x or f of x. So this is when you go back and say, okay, well, f of x is the original. And so this is our original. And then the g of x is our new. So between the original and the new, the one that is steeper is g of x. Oh, excuse me, not steeper, less steep, because it was changed. So this is g of x is less steep, I apologize. And then the f of x, which is the original, is the steeper graph. And I'm pointing that out because on your test, I might ask which graph is steeper. And you want to make sure you have it properly labeled. Question number 47. What transformation occurs when the graph of f of x equals 3x plus 2 is changed to the graph of h of x equals f of x minus 10? Once again, it doesn't matter what this original was. What matters is that you're changing it. It's being changed, and our new graph is here. Our new equation, how it's been changed. So When we look at this transformation, we're noticing we are subtracting and it's outside, which means we're affecting the y values. Once again, when you're looking at a graph, you're looking at the coordinate plane, x-axis and y-axis. The y-axis goes up and down, which means you're changing this by moving up or down. We look, there's a -10, it's outside the parentheses once again. So this graph is being translated down 10 unit. Okay, once again, it didn't matter what was here. What matters is what it was changed to. Question number 48 is asking us to describe the effect of the graph of f of x equals 3x minus 11 if the equation is transformed to h of x equals f of 7x minus 1. So once again, it doesn't matter what the original equation is. What matters is what the new transformation is. So this is the only piece of information we need. This original equation, not needed. So here we can see there's two things going on. We have a number inside that's being multiplied and a number outside that's being subtracted. So there's two things we're going to focus on. The first being inside. Inside, we are multiplying, which means we're talking about the steepness. The steepness is going to increase, so it's going to be steeper. And the reason why is because 7 is greater than 1, which is where it's steeper. And then at the end, that -1 is outside, which is affecting the y values. And once again, the y values goes up and down. So we're moving the graph either up or down, and we know it's going to be down because of the subtraction. And we're going down 1 unit. So our overall answer is the graph of h of x is steeper, and it was translated down 1 unit. All right, that completes all of the questions off the review that I've given you. Please, please, please bring it on the day of your exam, and also best of luck.